Hi everyone, this is Miss Peters. I'm going over stoichiometry example number 2. If you're in my class, this is your test review number 2. So the question, how much precipitate is formed if 10 grams of barium chloride reacts with excess potassium carbonate? And then how many formula units of potassium carbonate would be required to completely react with 10 grams of barium chloride? So first thing we need to do always when you have stoichiometry is write a balanced equation. And it doesn't tell you what the products are, but we can predict the products because we're told we have barium chloride reacting with potassium carbonate. So this is going to be a double replacement reaction. Whenever you have two compounds like this one, it is double replacement. So barium chloride. Barium is a +2. Chloride is a -1. So BaCl2 reacts with potassium carbonate. Potassium is a +1. Carbonate is a -2. So K2 is CO3. And that is going to form. Now when you do a double replacement, that is when the metal of one reacts with the non-metal of the other compound. So barium and carbonate go together. They are both a +2 and a -2, so BaCO3 plus, and then the other two go together, potassium and chlorine. Now we're not going to write chlorine, potassium, because you always write metals first in a compound. So potassium chloride, and that's a +1 and a -1, so there are no subscripts. And then this equation is not balanced because there are two potassiums and two chlorines on the left. So we'll throw 2 in front here. Now, I used my context clues and I saw the question asks for how much precipitate is formed. That is when you have two solutions that mix together and form a solid. So you need to go to your solubility rules. These are the solubility rules that I'm using. And so all of these compounds in the top box are soluble. That means they are aqueous. They dissolve in water. These at the bottom are insoluble. They are solid. They don't dissolve in water unless they're paired with an exception, and then they are aqueous. And if any of the aqueous are paired with an exception, then they are solid. So our first one is barium chloride. Chlorides are usually aqueous unless it's paired with silver, lead, mercury. Well, barium is not any of those, so that is aqueous. And then my product, KCl. K is not silver, mercury, or lead, so that is also aqueous. Now let's look at the carbonates. Carbonate is soluble unless it's with NH4 or an alkali metal. An alkali metal is something that is +1. It's so, I already wrote it up above, potassium carbonate is a +1. So because that is an exception, potassium carbonate is aqueous. But barium carbonate is not an alkali metal. Barium is a +2, so it is not an exception, which means it is solid. So in 2A, I'm going to be looking for how much barium carbonate, because that's my precipitate. So here we're going to just have more space. Let's write out our equation really fast. That's a 3. BaCO3, and again that's my solid, +2 KCl. Okay, so we always start our stoichiometry with our given in the problem, 10 grams barium chloride. So 10 grams BaCl2. When you don't start with moles, you have to change to get moles. The conversion from grams to moles is to find your molar mass, which is where you go to the periodic table and you add up 1 barium and 2 chlorines. And so for the sake of time, if you want to do that really fast, you can pause this video, but it is 208.234 grams. And I am writing that at the bottom, so grams of barium chloride cancel out. That's an O. If your periodic table is different than mine, your number might be a little different, but should be about 208. And then that many grams are in 1 mole of barium chloride. Anytime you go to the periodic table and you add up the grams, it is always 1 mole on the other side because that's how many grams are in 1 mole. It doesn't matter what the coefficient right there is. That could have been a 20 in front of BaCl2. It would always be 1 mole. So now I've canceled out my gram unit and I have moles. Once you have moles, you go to your equation and we use our coefficients. So the coefficient for BaCl2 is 1. And I'm going to write that at the bottom so that way moles of BaCl2 cancel. And then on the other side, I'm going to write the coefficient for the substance I'm solving for, which again was my precipitate, which is barium carbonate. And that is a 1 in front of that. So 1 mole BaCO3. Now, the problem doesn't say what unit it wants us to solve for, but typically when you're asked like how much solid is formed, you're going to answer in grams. So that's what we're going to do, which means I'm going to use molar mass again, but this time I'll use the molar mass of barium carbonate, or BaCO3. So whenever we use molar mass again, it is 1 mole. 1 mole goes at the bottom, that way mole units cancel out. Boom, boom. And then I'm going to write the molar mass of barium carbonate up top. You go to your periodic table, add up 1 barium, 1 carbon, 3 oxygens, and you should get 197.336 grams. And then to solve, multiply across the top. So 10 times 1 times 197.336 divided by what you multiply across the bottom. And you should get an answer of about 948 grams barium carbonate. Our next example, how many formula units of potassium carbonate would be required to completely react with 10 grams of barium chloride? Formula unit is the same thing as particle or atom or molecule. It's just a different word. And so that's what we're looking for, molecules, particles. Same thing, which means we will use Avogadro's number. Now, Avogadro's number is 1 mole of any substance equals 6.02 times 10 to the 23 particles, in this case formula units. We'll abbreviate it FUN, because chemistry is fun. That's a joke. Not a good one, but. So, this problem, we start with 10 grams barium chloride. So 10 grams BaCl2. So this is going to start just like our other problem. We're going to use our molar mass and go to moles. So 208.234 grams barium chloride are in 1 mole barium chloride. And then we're looking for formula units of potassium carbonate. That is the K2CO3. So now I'm at moles. I've gotten rid of my gram unit. I'm going to use my mole ratio. For both of these, there's a 1 in front of it. There's nothing in front of them, so that's a 1. But that's not always the case. That is why we can't like skip this step. Like, why do we have to write this? Because when it's not a 1, it changes your answer. And so moles of barium chloride cancel out. We're left with moles potassium carbonate. And now we can use Avogadro's number, which is this conversion. And so because I have moles K2CO3 at the top right here, I got to write 1 mole K2CO3 at the bottom, and then Avogadro's number up top. And then to solve this, typing in scientific notation in the calculator isn't easy, and so pause this video. I want you to type this in and make sure you have it correct, and then hit play when you get the answer. And you should get 2.89 times 10 to the 22 formula units. If you don't get 10 to the 22, something's going on when you type in your scientific notation. often. And so maybe go search on YouTube how to do scientific notation on your calculator so you can fix that. And I hope this video was helpful.